8.6, the closing section of Chapter 8. We're just going to identify special quadrilaterals. So looking at the breakdown of quadrilaterals, we have a kite, which has two pairs of congruent consecutive sides, parallelogram, which has opposite sides congruent, and a trapezoid, which has exactly one pair of parallel sides. And then the breakdown, within a trapezoid, you have the isosceles trapezoid. Within the parallelogram, you have the rhombus, the rectangle, and the square. So what you'll need to do in this section is just recall those properties. So if we have both pairs of opposite sides congruent, we're going to check off or put an X in the box for all of them that apply. So both pairs of opposite sides are congruent is a parallelogram. And if it's a parallelogram, it's a rectangle, a rhombus, a square. Both pairs of opposite angles are congruent. Again, that's a parallelogram. So it'd be a rectangle, a rhombus, and a square. Exactly one pair of opposite sides are congruent. So thinking about that, I only have one pair, exactly one pair of opposite sides congruent. I don't know that any of them apply. A trapezoid doesn't have opposite sides congruent. If it was an isosceles trapezoid, it has the legs congruent. Exactly one side of opposite sides parallel. That is a trapezoid. Exactly one pair of opposite angles congruent. And this next to last is a kite. That is a kite, only has one pair of opposite angles. And consecutive angles are supplementary. Well, that would be a parallelogram. And if it's a parallelogram, it's a rectangle, a rhombus, and a square. So it is possible to have something that will not apply to any of them. Give the most specific name for the quadrilateral explained. So explaining, first off, what do we have here? We have one pair, parallel sides, and one pair, base angles congruent. So that's an isotrap, or an isosceles trapezoid. What do we have here? We have 4 congruent sides, and we would have 4 right angles. We could very easily know that that 4th angle is a right angle. So this is a square. In this one you have 4 congruent angles, which makes them right angles. So this would just be a rectangle, even though it looks like a square. We don't know anything about its sides. And here we just have opposite sides parallel. This would just be a parallelogram. Okay, do we have enough information in the diagram to classify the quadrilateral by the indicated name? Well, what do I see here? I see congruent diagonals, because that makes these 4 segments here. That lets me know the diagonals are congruent. So yes, and it's already a parallelogram, so that works. An isotrap, we have base angles here, base angles here, they're congruent. One pair parallel sides. So this is going to be a yes. In the last section, we're going to see what pair of segments or angles must be congruent so that we can prove that ABCD is the indicated quadrilateral. Okay, and there can be more than one right answer, so I'm going to try to give what I can for each of them. I think the easiest thing, since I only need a pair of segments or angles, for this, it's a parallelogram, is I need the diagonals. The diagonals. If I had the diagonals congruent, that would be a rectangle. To make a parallelogram from one pair of opposite sides, just have the other pair of opposite sides congruent. And for an isosceles trapezoid, I just really need a one pair of base angles congruent. Another option would be to have the legs congruent. And this ends lesson 8-6. Homework is posted.